Hi, it's Joe Scheinberg from Intel. In this video, I'm very excited to share some technology I've been developing around Intel RealSense face scanning. For detailed documentation and source code, check out the links in the video description below. This is the second iteration of the face scanning code sample. In the video for the first sample, I scanned my face and then mapped it onto a static head mesh. This had reasonable results, but it could be better. For one, the shape of the head was static and usually didn't match the shape of the person being scanned. The previous sample also required a dense vertex grid for the facial area of the base head mesh. Further, when the depth information from the scanned face was extruded from the head mesh's facial area, the context of each vertex was lost, which breaks any facial animation data attached to the original head mesh. The sample in this video addresses these problems. The user can shape the head using a series of morph targets before the face is mapped. A new mapping algorithm is also used to lower the vertex density of the facial area and retain the context of each face vertex. For example, a vertex found on the tip of the nose in the original base head mesh will be on the tip of the nose after the face mapping is complete. This means that animation data authored for the original base head mesh can be applied to the resulting head mesh. The sample allows the user to scan their face, but in this video we're going to start off with a previous scan of my face. See the previous video if you'd like to see the scan process in action. Here's the scan we'll be using. This is the mesh and landmark data generated by the RealSense SDK. Similarly to the first sample, the face scan is rendered into a color and displacement map, and the face landmarks are transformed into map space. The mapping process begins with an artist-authored base head mesh and associated landmarks that coincide with the face landmarks provided with the SDK. The user can apply morph targets to the base head mesh to build the shape of their head. After applying the morph targets, the head vertices are projected onto an authored landmark mesh. The landmark mesh is then morphed using the face scan landmarks, and the vertices are reprojected. The landmark mesh can be thought of as a map that shifts vertices to maintain their context. All this shifting is done on the X and Y axes. Once completed, the generated face displacement map is used to extrude the face shape. The blending stage is similar to the last sample. The head textures, face textures, and user-selected colors are all blended together on the GPU, creating a diffuse texture that uses the head mesh's texture coordinates. Here's what the end result looks like. The default head colors don't quite match my scan, so I'm going to adjust the saturation on them to remove some of the color. Looking at the head mesh before and after the mapping, you can see that the context of the vertices have been preserved. The sample includes multiple hairstyles that morph to the head's shape using an algorithm that's described in detail in the online documentation. We have a short transparent hair, a medium length transparent hair, and then we have a short opaque hair and a long opaque hair. Once the face is mapped and we're happy with the result, we can then start to apply post effects such as change the colors, change the shape of the head after the face is mapped onto it. For example, we have a morph target that's the shape of an ogre. Let's apply it as a post effect. Next, let's apply a colorized post-blending effect. The colorized effect allows changing the color while preserving the luminance of the texture. Two colors are supported, so let's tweak them to make our ogre green with a little bit of brown highlights. This shape and coloring was pretty easy to apply, and not particularly creative. The artist made the entire morph target. What's really interesting is when you start combining morph targets and coming up with strange characters of your own. For example, we can increase the ear size vertically and horizontally. We can make the ear rotate forward. We can decrease the body mass index or increase it. And we can apply just a touch of ogre. The sample includes about 40 morph targets, so there's really a lot of possibilities about what you can make. Here's a collage of some crazy characters that I built using the sample. Well, that's all I have to share in this video. Thanks for watching, and please download the sample, see what you can create with it. If you create anything cool, share it on Twitter with #IntelGameDev. Thanks for watching.